Hello, my name is Carol Christensen. I'm the Warning Coordination Meteorologist at the National Weather Service office in Duluth, Minnesota. And I'm going to give you a little presentation about the radiosonde, or what many of you will know it as the weather balloon. The weather balloon, or the radiosonde, the sonde itself is a piece of equipment that we tie onto a big helium or hydrogen-filled balloon, and we let it go up into the atmosphere. As it goes up into the atmosphere, it collects data for us. So it's a weather sensing equipment, and this information that it collects is radioed back down to us as the instrument ascends up into the atmosphere. And this instrument collects data like winds, temperature, humidity, pressure, and altitude as it rises. And it rises at about 1,000 feet per minute, and it can rise to over 100,000 feet before it bursts. And the balloon bursts because as it rises higher and higher into the atmosphere, it expands. It gets bigger and bigger and bigger, and eventually it will pop. Once the balloon pops, the equipment will fall back down to Earth. Well, when it falls back down to Earth, we don't want it to hit someone or something and cause damage. So this parachute, this red thing here, is a parachute. The parachute will open up, and the instrument will float gently to the ground. We don't need this instrument back because we already have the information. However, people can find these because they fall wherever the winds have taken them, and people find them. And when they find them, there's a mailer tucked inside the instrument, and there's instructions on how to return the instrument back to the National Weather Service so we can reuse it. The radiosonde, the weather balloons, are launched twice a day all over the world. We have over 800 sites across the world, 100 sites here in the United States. And they're launched at the same time every day all across the world because we want all the data to be collected at the same time. So it's collected at 00 coordinated time and 1200 universal coordinated time, or our time, 6 a.m. and 6 p.m. Central Standard Time. The closest for the Northland would be International Falls, and we have been launching balloons there for years, and we have Weather Service contractors launching balloons twice a day from International Falls. And we also have Minneapolis and Green Bay in locations around the Northland. This is what the data looks like from the radiosonde. So we have the pressure and the height and the temperature in degrees Celsius as it's rising, dew point, humidity, winds aloft also. So here I just cut out a bunch of the information, and here we're all the way up to 30,000 meters, 32,000 meters. As it goes up, we can see how the atmosphere responds. The data is directly input into our weather prediction models. It's also used for weather and climate research, air pollution models, hazardous material models, and ground truth for satellite data. It's used for many different things. Here's a picture of one of the classes in the past during the balloon festival getting ready to launch their weather balloon. And that's what many of the classes will be doing during this year's balloon festival down in Duluth. And this is what the data looks like plotted on what we call a skew-T diagram. We have the temperature at the bottom. So we have, and it's in Celsius, so here's 0 degrees Celsius, 30 degrees Celsius, and down here we have major negative degrees Celsius, minus 70, minus 60. This red line is the temperature profile as the balloon rose. So we can see here that as the balloon rose up into the atmosphere, because this is height over here, we can see that the temperature decreased as the balloon rose. Except look what happened here. once it got up to over 12,000 meters, the temperature did not rise or did not decrease anymore. In fact, it was steady for a while and then increased. Well, that tells us that that is where the troposphere ends and the stratosphere begins. And in the stratosphere is the area where our greenhouse gases are. And because we know that the greenhouse gases trap heat, where it's showing us very clearly where the stratosphere is, where the temperature actually stays the same and then increases with height. And this other green line here is the dew point line. This is the measure of how much moisture was in the air as the balloon rose up into the atmosphere. And that's the area where I was talking about where the ozone layer is, or the stratospheric layer is. So the information is used by many different people. Here it's used by the National Weather Service office in Duluth. That's our office, and there I am talking on the phone. There's forecaster Dean Meldy working with me that day. And we also use it to look at different weather models and weather maps. Here's a forecast radiosonde sounding that we use to help forecast the weather. And all sorts of other people also use the data. Pilots, balloonists, photographers, boaters, I can go on and on. It's very useful information. So let's talk about your launch. Many of you are going to be launching a weather balloon with us at the Balloon Festival. So we're going to talk about the steps that we're going to take when we launch our weather balloon. And here's the Hibbing School ready to let go of their weather balloon, and you'll see here we use lots of string, so we're going to need lots of kids to help hold that string. Well, this is what our equipment looks like that we use at the National Weather Service. Here's the balloon, here's the parachute, and here's the radiosonde equipment that we launch. However, what we're going to use at the Balloon Festival or when we go up to a school is a platform, and on that platform will be a GoPro camera, and we'll have a geo tracker so we can actually track the balloon, see where it goes and see where it lands. And we're going to have the data collection, the sonde itself that collects data as it goes up into the atmosphere. So we're going to have to tie lots of strings. So here we have the Marshall School tying all their equipment together, and here we have the platform itself, and we're putting all the equipment onto the platform. So here we are getting the payload ready to launch. And then, once we have it all tied together, then we have to blow up the balloon. And it's a big balloon, and we're going to need some kids to help hold, or students to help hold the balloon as the helium is put into the balloon. And notice that we're all wearing gloves, because we don't want our oil on our hands to be transferred to the balloon, because that could make the balloon pop prematurely, so it won't go up as high as we would like. And here we are still blowing up the balloon. Here's the helium canister, and we have the students holding onto that balloon pretty tight. And then the next step is we have to tie off the balloon. So we have to get into this area, and we have to tie off the balloon, and that's almost the hardest part sometimes. So we have to keep we have to keep hold of the balloon, but also tie it off. And then here's a picture of the payload down here at the grass. This is up in Hibbing a couple years ago when we launched the balloon. Here's the payload, here's the parachute. We have lots of string to hang on to, getting ready to let it go. And there we have down at Bayfront Park, we let it go. Here's a really good picture of what the payload looks like. So as the payload is launched up into the atmosphere, we're getting video of the whole thing. And here's an example again. There's the parachute, lots and lots of string, and ready to let it go. And here we have a launch, a successful launch in Hibbing 2 years ago. And we have the balloon, the parachute, and then we have the payload down here. Now remember, it rises about 1,000 feet per second, so it goes up very quickly. And it goes up for about an hour before it pops, and takes about another hour to come back down to Earth. Here's another picture of a launch in Hibbing. Here again, we see the balloon, we see the orange parachute, and the payload is down here, ready to go up. And here's a picture of a still picture from the GoPro camera as the balloon was ascending over Duluth. And here we can see a lot of Duluth as the balloon was rising. Here's some tracks from past balloon launches. Here was Marshall back in 2013. And you can see how the upper level winds changed with height. So we launched it in Duluth and over here, and then the balloon traveled over the lake and eventually came down in a swampy area over northern Wisconsin. And here's another track of the Hermantown Middle School launched it in Duluth down at Bayfront Park, and it kind of floated around Duluth for a while until it rose high enough that it got into the upper level winds were from the northwest, and took that balloon all the way down into northern Wisconsin again. Another example, this was launched in Hibbing, and the balloon moved almost due east, straight toward Lake Superior, where we were watching it and getting awfully worried, but it came down very close to Lake Superior, maybe a quarter mile to a half a mile away, into someone's backyard. So thank goodness it did not go into the lake, and we were able to retrieve the payload. And here's another example from back in 2014. We launched it in Hibbing, and we had some pretty strong south winds near the surface, so the balloon went north for a while and then got caught up into some strong westerly winds and floated out across the Iron Range area, and then went back. As it came back down again, it got caught up into the southerly flow again and landed in a tree. But we were able to retrieve all of these balloons or payloads. So we'll see you at the Balloon Fest or at your school, and I'm really looking forward to helping you launch a weather balloon.